Alright, good evening, Eric. This is Sturch broadcasting from the Mushroom Edge in Taos, Mexico, working in oil painting Thoughtless.
This theory has many implications.
Alright, I'm just going to start in with some layering, beginning with translucencies. I'm going to start with some ultramarine blue in the shadow areas, some Naples yellow, and then very slightly blended Naples yellow and white for highlights.
I'll come back to that in a moment, but this is just to give the brief overview. Now, the idea of morphic resonance, memory in nature, is rather shocking in Western science. Indeed, it's been proclaimed a heresy by some scientific authorities because it goes against the usual assumptions of Western science, which are that nature is governed by fixed eternal laws. And this idea of fixed eternal laws goes back a very long way. Pythagoras in ancient Greece had the idea that there was an eternal reality which this reality reflects. In fact, all the ancient Greek philosophers thought that there was an eternal reality that this changing world was a reflection of. They had different theories about what the eternal reality was, and Pythagoras thought it was mathematics, numbers, ratios, proportions, harmonies. And he thought that the mathematical realm was the truly real realm, and everything in this world was a reflection of it. Now, Plato generalized Pythagoras' idea, so it's not just mathematics that's eternal, it's all the realm of forms and ideas, the shapes of everything, red cedars, horses, cats, hedgehogs, all these, everything in nature has an eternal form or archetype in a transcendent realm beyond space and time, the realm of Platonic forms or ideas. And in the beginning of the 17th century, when the scientific revolution got going, the founding fathers of modern science were all believers in this kind of Platonic Pythagorean cosmology. They thought that the laws of nature were mathematical, that they were discovering the mathematical principles of nature which were ideas in the mind of God, that for them God was a mathematician. Mathematicians very much like the idea that God's a mathematician because it means that they're the closest of all humans to the divine, and also automatically a kind of priesthood because most of us don't understand much maths. And that means that mathematicians have this privileged role in our society. So they all like that idea, right up to the present. Your most hard-nosed atheistic physicist is usually a secret Platonist. So the idea that all the laws of nature are eternal, that nature is governed by fixed laws, is really built into the foundations of Western thought. It's not built into the foundations of Eastern thought. In Hinduism and Buddhism, it's taken for granted there's a kind of memory in nature. And when I came up with the idea of morphic resonance, I was working at Cambridge doing research on plant development. And I came up with this idea in terms of understanding the inheritance of form in plants and animals. I didn't come up with it by studying Eastern philosophy. I hadn't studied Eastern philosophy. But when I then later went to work in India, I spent 7 years in India, when I explained morphic resonance to my Hindu friends, most of them were deeply unimpressed. They said, oh, this is an ancient idea, rishis said this thousands of years ago and stuff. And they just thought, what's new? We've heard all this before. Whereas in Cambridge, when I talked about the idea, there was shock and horror in the scientific realm. Now, I think that actually, although Western science has been based on this eternal law principle, it's in a state of crisis. Until 1966, most scientists thought the universe was eternal, and having an eternal universe governed by eternal laws made sense. Since 1966, we've had the Big Bang cosmology. The whole universe started very small, less than the size of a head of a pin. It's been expanding and cooling ever since, and as it grows and cools, new forms and structures appear within it. It's much more like a developing organism than like an eternal machine. So in this evolving universe that we live in according to modern cosmology, everything evolves. But they've still gone on with the idea that the laws of nature are fixed. So they assume that all the laws of nature were all there in place like a kind of Napoleonic code at the very moment of the Big Bang. They don't explain how they got there. Many scientists are atheists, so they just assume there were these free-floating laws that were somehow there, or which came into being with the universe itself, together with all the matter and energy in the universe. And as my friend Terence McKenna liked to say, modern science is based on the principle, give us one free miracle and we'll explain the rest. And one free miracle is the appearance of all the laws of nature and all the matter and energy in the universe from nothing in a single instant, for no reason. Anyway, we now have this radically evolving cosmos, and most scientists assume that all the laws were there at the beginning, and then they have endless debates about why were the laws exactly as they were and not otherwise. And then there's a huge debate in modern cosmology. One lot of people say, well, if they're exactly right for the universe that's just right for us, and there could have been billions of alternative universes, then there must have been an intelligent designer, a kind of external engineering god who fine-tuned all the laws and constants so it was just right for us before pressing the start button. And that's one view, a kind of external mechanistic god. The other view, to avoid an external mechanistic god, is to say there are billions, about trillions or quadrillions of actual universes. We just happen to live in the one that's right for us, and all the others actually exist. And when I asked one of the proponents of this, this very extravagant hypothesis, contravening Occam's razor, the principle you should have the minimum number of entities in an explanation, I said this is the ultimate violation of Occam's razor. You know, quadrillions of universes for which there's not a shred of evidence. I said, how on earth can you believe in that? He said, well, this way we can get rid of God. But as theologians have pointed out, it doesn't even get rid of God, because an infinite God would be the God of an infinite number of universes, or could be. So anyway, they're locked into this debate, the universe versus the multiverse, and seminars and conferences and learned discussions go on in universities about this, all based on the assumption the laws were fixed at the beginning. But if we're in a radically evolutionary universe, why should the laws be fixed at the beginning? Why shouldn't, if they're laws at all, why shouldn't they be more like common law in the English and American system, depending on precedents? In fact, why shouldn't they be more like habits? The minute you think about the idea of laws of nature, you realize that it's a deeply anthropomorphic concept. Only humans have laws, and only civilized humans have laws, in fact. Tribes have customs. So the idea of laws of nature is a very peculiar idea, the more you think about it. Habits makes much more sense. And that's what I've been saying since I put forward the idea of morphic resonance in 1981 for the first time. Since then, cosmologists, including Lee Smolin, who's a theoretical physicist, have indeed started talking about the habits of nature, and they are coming round to this idea. But I mean, they'll have to come round to it, because it just doesn't make sense to have this hangover from the old Platonic cosmology sort of tacked onto a radically evolutionary worldview. Well, this way of looking at nature provides a very different interpretation of many physical phenomena. For example, when you crystallize a new chemical for the very first time, according to the standard view, the way it forms is already predetermined by the laws of electromagnetism, quantum physics, thermodynamics, etc. And in principle, you should be able to predict the form of the crystal. In practice, you can't, it's too complicated. But in principle, you should. And the first time it forms, and the millionth time, and the billionth time, it should be exactly the same, because the laws are the same at all times and in all places. According to morphic resonance, the first time you make the crystal, it may take a long time for the new crystal form to come into being. And when you make it repeatedly over and over again in labs all around the world, new habit builds up, and the crystal should crystallize more easily. And that's exactly what chemists find. Crystals get easier and easier to crystallize. But of course they don't explain it in terms of morphic resonance, they explain it in terms of, firstly, anecdotes about chemists carrying seeds or nuclei, little bits of previous crystals around the world on their beards or clothing, or secondly in terms of dust particles from previous crystals being wafted around the world in the atmosphere. What I'm saying is that this should happen even when bearded chemists are excluded and when the dust is filtered from the atmosphere. And also this theory predicts the melting points of crystals, which are called physical constants, should go up as time goes on because the crystals get more stable through morphic resonance, the form becomes more habitual, and therefore it should be harder to break the form down. You need a higher temperature to do it. And actually, the melting points of new compounds do go up, sometimes by 10, 20 degrees. I've studied this with hundreds of chemicals. And most chemists simply, they have to acknowledge the fact that this is happening, even though these are supposed to be physical constants. But they say, well, it's just because we get better at making the crystals, and they're purer samples, and purer samples have higher melting points. But it's incredibly difficult to get them to test this hypothesis. And it's already been tested through everyday practice of chemistry, but the facts fit very well with morphic resonance. In the realm of animal behaviour, there's a well-known example of rats. A long series of experiments at Harvard, Edinburgh and Melbourne University in Australia showed that when you train rats to learn a new trick, escaping from a water maze, the more rats that learned it, the easier it got for other rats to learn it, even in other parts of the world. And this wasn't just rats that were descended from trained rats who might have inherited this epigenetically, but it was all rats of that breed, even ones whose parents had never been in the water maze before. Now, I think the same is happening in the human realm. I think it's getting easier to learn things other people have already learned. There's already lots of evidence for this. IQ tests, for example, have got at least 30%, the scores, on average scores on intelligence tests have got at least 30% higher over the last decade, so throughout the 20th century, ever since they were invented in 1918. There's no independent evidence that people are getting smarter. If anything, they're not doing as well on other exams, because of dumbing down, effects of TV, etc., low attention spans. I think they're getting, the IQ scores are going up because so many people have done the same tests, they get easier to do. And I would predict that Wordle should be getting easier to do throughout the day, from the moment it's published in the morning, throughout the day, as it goes on, and every single day there's a new Wordle puzzle. And I would predict if you could get access to the data that there would be an increasing rate of score throughout the day. I first got onto this through people writing and telling me in the 1980s that they found the Times crossword puzzle easier to do if they did it in the evening or the next day. Because, and some people had noticed this anyway, they left it till the evening to do it. It was more satisfying to be able to succeed with more clues. So I think morphic resonance is working in these very practical things. When I thought of testing using Wordle as a test, the very day I thought of it, I wrote to the inventor of Wordle, but that very day it was bought by the New York Times. And so I tried to get the New York Times to let me see the data, and I thought cold calling the New York Times wasn't going to work. So one of Merlin's friends is an editor at the New York Times, so through Merlin's friend I got access to the head of games at the New York Times and asked her if we could look at the data from the point of view of seeing if this was really happening. And she was a terrible spoilsport. She just wrote back saying the games department are not interested in this project at this time. So unfortunately, they've got all this data and it's can't get hands on it, but there's something called caudal and octaudal and what's the other one's children? Dawdle, yeah. So anyway, there's all these other versions of Wordle which may be more accessible for looking at the data. I'm going to try and get in touch with them when I get back to England. So I think that there's already been quite a number of experiments on learning, morphic resonance facilitated learning. And it should affect learning. It should be easier to learn things lots of people have learned, and the more that learn it, the easier it should get. And this should apply to skateboarding, snowboarding, windsurfing, all these new physical skills, as well as mental skills. And when I talk to people in those areas of activity, many of them say, yes, indeed, it's getting easier to teach, but the trouble is you can't disentangle better equipment designs, training videos, etc. from morphic resonance. So it's hard to use that as evidence. One needs more special situations, and Wordle would be really good for this. This hypothesis is still controversial, and many scientists are scared of it, really, because it would overthrow so much of established science. I mean, actually, business as usual could still go on, because if a habit's strongly enough established, it behaves almost as if it's governed by an eternal law. The habits of hydrogen atoms, which have been going on for 13 billion years, are probably, you hardly tell the difference from an eternal law. But when something's new, that's when you notice the difference. And that's why to test morphic resonance you have to look at new patterns of behaviour, new forms of animals, new chemicals, new crystals, etc. Now this has many implications in different realms of science. And one is for inheritance in biology. Living organisms inherit a great deal from their ancestors. And the usual assumption is that this is genetic. Many people use the words hereditary and genetic as synonyms. If it's inherited, it must be in the DNA. DNA is a chemical molecule. And we know what DNA does. It enables cells to make proteins by spelling out the sequence of amino acids, which are the building blocks of proteins, which are strings of amino acids, which then fold up. But DNA spells out the sequence of amino acids in the primary string within a protein. Well, that's what it does, and some DNA controls the activity of other DNA, it switches on and off genes. But that doesn't, making the right proteins doesn't equate to the shape of your face or your arms or your legs. It just enables you to have the right proteins. It's rather like saying having the right building materials would explain a house or a cabin. It doesn't. You have to have them to build a house or cabin, but the plan of the house, the architectural plan, is not in the genes or in the building materials or in the DNA. And I think that it's inherited through morphic resonance, through the forms of previous organisms. When the Human Genome Project was completed in 2000, the assumption was that they'd soon be able to predict all details of human beings based on the genome, and that you could patent genes and that you'd be able to predict exactly which diseases people would get with great accuracy and so on. It turned out not to work out that way at all. Soon after the human
Still got
genome
10
was
minutes on this
sequenced,
memory segment,
the
considering
share price
breaking
of
out
these
a
genome
little bit more
sequencing
black
companies collapsed.
to
Cellular
deepen the
Genomics,
deepest
private
part of
genome
the
company headed
longest
by
blue
Craig Venter,
shadows. I
collapsed
kind of
from
like the
$64
translucency,
a share to
so I'm not
about
sure if I want to
15
come into a
cents.
deep,
And
dark,
shortly
opaque,
afterwards, when
solid
interviewed
at the
Craig
base of
Venter,
those shadows
said,
yet.
I'm a guy
Let me
who's
think
made
for
a
a second
million in a
here.
hard way by working my way down
It's starting
to
to
a billion.
develop. From here, there will be more translucent,
And
globular
and it turned
shapes
out to be almost
floating
useless. And
throughout
by
the composition,
2008, it's
still
become clear
retaining her
in
form,
biology
but
that there's
dissolving
a
it
major
somewhat.
problem called the missing heritability
So,
problem. That
think about how that's going to lend
you
to
could, if you knew all the
10 more
genes
layers.
of a person, you could predict their likelihood
Alright,
of
well,
breast
I
cancer.
think I'm going to leave it there
or
because
schizophrenia or
that needs to
something
set
like
up if I'm
With
going
an
to layer it with
accuracy
more
of
translucencies,
less than
and the
10%,
black might
or
anchor the
6
shadows
about
too much
3%.
through other
Even
translucencies.
for
So,
height, which is a
yeah,
fairly
that
obvious
gets the
physical
figure set up pretty
characteristic.
well,
You
and the
can
ground
explain
defined
about
enough
10% in terms
to
of genes.
start building from there. So
So
that's it for the moment. Have a
where's all the
good
rest
night,
of the
Earth. Thanks, Adam
inheritance
Search
coming
Podcast,
from?
up in the mushroom
This
land
is
in Taos,
called within
Mexico,
biology
working
the
on
missing
oil
heritability
painting
problem.
thoughtless.
Part
Let me
of it, I
zoom
think,
out
is due
so
to
YouTube doesn't block me for the
epigenetics,
presence
which is
of
the
painted
inheritance of
nipples.
acquired characters.
Stupid
Those of you
fucks.
who were at school
Have a good night,
or
everyone.
university in